Hello, this is Zeshan from the University of Sydney. Now we present our work called Recurrent Glimpse Decoder for Detection with Transformer. First of all, I would like to introduce the object detection task. Detection aims to recognize objects of interest and locate them by giving their coordinates. Current typical methods fulfill detection mainly based on highly redundant and overlapped detection results, which require non-maximum suppression to reduce such redundancy. Recently, researchers from Facebook AI introduced the detection transformer framework called Decoder that can perform detection in a fully end-to-end pipeline without the need of NMS. One of the major obstacles that affect the progress of Decoder research is the difficult training problem. It will take an extremely long time to make Decoder converge. Using MS Coco dataset, the original Decoder requires 500 training epochs to obtain promising performance, while the FPN only requires less than 36 epochs. By analyzing this problem, many researchers have found that the difficult training problem could be attributed to the inefficient locality modeling in transformer. Since the transformer would distribute almost the same attentional weights to all feature interests initially, it would take quite a long time to make the attention focus on sparse and meaningful local areas. By addressing this issue, many methods have been developed by introducing either advanced multi-skill feature encoding mechanisms or improved object query embedding designs. Different from current studies, we propose that region of interest can easily help improve the locality modeling of transformer by focusing its attention on more meaningful local areas. Directly incorporating ROS to Decoder may not be an easy task. On the one hand, if using typical ROS-based detection method like RCN after the Decoder, the AMS would still be needed. On the other hand, if extracting proposals as ROS before Decoder, the benefits of global attention modeling in transformer would not be easily enjoyed. To effectively incorporate ROS with Decoder, we are inspired by the glimpse mechanism studied in a paper, which selects a few local areas of different skills as glimpses and progressively process them to facilitate the recognition of characters. We propose that information from ROS can also be gradually added to the attention modeling of Decoder. Besides, multi-skill visual cues can further help gradually narrow attended areas for Decoder in a more sensible and robust way. Based on above motivation, we propose a recurrent glimpse decoder module called REGO to help improve the training and the detection of different Decoder methods. The figure shows the overall logic. Using original Decoder results, we implement the REGO based on a multi-stage ROI-based attention modeling refinement procedure by gradually focusing on more accurate areas. This is a walkthrough of our method. For the S stage, we first enlarge the previous detection results as ROS, and then we collect visual features from ROS as glimpse features. We project the glimpse features into a query representation. In the meantime, we perform the linear projection on the previous decoding output to obtain key and value representation. With the query key and value, we employ a transformer decoder to translate the input features into a refined glimpse representation. And we concatenate the refined glimpse representation with the previous decoding output to obtain the current glimpse decoding output. And we apply an MLP to transform the current glimpse decoding output to the current detection output, which will be recurrently sent to the next stage. By implementing the REGO, we can find that the convergence speed can be accelerated. In addition, we also present the detection performance of our method with other detection methods. We can find that using the same backbone and same training epochs, our method achieves better performance. And even using the fewer training epochs, like 36 epochs, our method achieves comparable and even better performance than the baseline trained at 50 epochs. Our REGO can also improve Decoder for free. By training with REGO but inference resulted, the baseline Decoder can still be improved. And the REGO helps reveal the relationships between objects. To conclude, ROS can indeed help improve the training performance of different Decoder methods, and multi-skill ROS and recurrent modeling are effective for cooperating ROS with Decoder without altering end-to-end detection pipeline. For future research, we think that the efficiency can be further optimized for the REGO, and more dynamic glimpse selection and extraction mechanisms can be explored. Thank you for your attention.